So far, we've been talking about surface area and area. Let's take a step back for a second and think about how this all relates to each other. Because we've been kind of introduced to 3D shapes, but I want to talk a little bit about the other dimensions. So there's 3D, right? So the first D is a dimension of length, and you can find that out with a ruler. Dimension is the first dimension is the length, right? So length is the first dimension, and we measure it with straight lines, right? So if you pull out a string can be thought of as a one-dimensional measure. Now the next level up is two dimensions, and you have length and width, right? So you can measure one dimension and the second dimension, and it's measured in square inches or square centimeters, or you can think of it kind of as tiles. So the area of this would be 4. Then the third dimension, so this is 1D, 2D, 3D. So 3D has length, width, and depth, right? And if you've seen a 3D movie, it comes at you, right? So 3D depth. So when we have something that is three-dimensional, we have length, width, and depth, right? So going into the page. So that is measured by what we call cubes. So this shape right here, it has so many cubes that make up its shape. And I can go around and count them. On the top layer, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 on the top layer. And then there's 3 layers that are identical to that top layer. So 3 times 9, there would be 27 cubes that make up this shape, right? And there would be here, it would be 4, and there's 2 layers of 4, so 4 times 2 would be 8. So there's 8 cubes that make up this shape, right? And that's what three-dimensional things that we're looking for. We analyzed these prisms and pyramids and found surface area. Now, they were three-dimensional shapes, but we were really only concerned with how many tiles go on the surface, right? Or like in this case, how many stickers would go on this shape, right? And we can think of it as, well, there's 9 on this face, 9, 9, and 9. So 4 times 9 to go around would be 36, and then 9 here and 9 there. So actually it'd be 9 times 6, or 54 stickers would go on this shape. That's surface area. But if I wanted to find volume, see, it's not 54. It was 27, right? 9 times 3. So there's a different amount of cubes that take up that space, and the same thing goes with this prism. It would fill up with so many cubes that were 1 by 1, right? So that's what we were looking for when we talk about volume. Okay, before we were looking for area, and in 3D shapes we called it surface area. In 2D flat shapes like the triangle and the rectangle and the circle, we were just finding area, and then surface area for 3D shapes. And then length, we just find the length. Or with shapes, we can find the length around something, right? What do we call that? The length around something. We call that the perimeter. Or in the case of the circle, I think that's what. And then the circle, right? Instead of perimeter, we call it circumference. Okay, so we have length, perimeter, circumference are all one-dimensional measures. Area, surface area are all two-dimensional measures. And then volume is a three-dimensional measure. And it's measured in. So we have these units here. The units also are important. So we have inches, centimeters, meters, feet, and here we have square inches, and it could be SQ. You might see it like this, square inches, or you might see it as inches squared. And that's kind of using the idea of when you have a square, right? You multiply the length times the width, and this makes it squared, right? And then in volume, we're looking for cubic inches. CU inches is usually the way that's abbreviated, or you could see it like this, inches cubed, and that's the geometric reason for that is that when you have inches that are in a cube shape, it's length times width times depth, and that's how we get this. We say this little superscript of the third power is called cubed, and that's where it comes from. Okay, we're going to have a couple of exercises on this using pyramids and prisms, cylinders, and cones.